The second question in our vectors booklet starts with another straightforward part A, find the vector P to B. So P, point here, to B, point here, and the obvious pathway is one that we can't currently travel along, so we're going to have to take the route PA followed by AB. Now the first part of the route P to A is broken up into two parts. This first part to get to N is B, but going in the wrong direction, so negative B. This second portion again is going in the wrong direction of 2B's, so negative 2B. And then our final portion here is travelling along with the direction of the vector A, so plus A. The question doesn't ask us to simplify, but we will. So minus 1B minus another 2B's is minus 3B plus A. And it's always useful now that we can put that vector onto the diagram. So point P to point B going in that direction is minus 3B plus A. As we then move into the second section, we're given some other information which is probably going to be really important, so we'll mark that on the diagram. Point B is the midpoint of line AC, so that tells us that this length here is the same as this length here, so we can add in now that this vector must also be A if they're the same direction and same magnitude. And it also tells us that M here is the midpoint of this vector, so this part here is going to be half of this vector, and this part here is going to be half of this vector, which we might need to come back to later. It then asks us to show that line NMC, so we've got N to M here, so if we mark that off so that we can say what we're talking about, part N to M, so this portion here, and M to C, so this slightly longer portion here, are a straight line. And the first thing we need to remember with vector questions is if we're trying to talk about straight lines and show that they're straight, we need to be able to show that they have an equal gradient, because lines with the same gradient are straight. Lines with a different gradient, for example, might do this, or possibly might do this. So we're looking at lines that are going to remain with a constant gradient and therefore form a straight line. So let's look at those two parts. Let's do vector N to M first. So points N to M, we're going to, looking back at our diagram, we're going to travel along from N to P, which is going in the right direction of B, so that's going to start with a positive B. And then we're going to travel along half of the vector we just discovered in part A of the question, because we're travelling from point P to point M, which we were told was the midpoint of PB. So we're now going to add to our vector half of the vector we just discovered, which was minus 3B plus A. Now we're going to need to do some tidying up of that so that we can come back and refer to it later on. So we've still got our positive B. We've now got half of minus 3B, so that's going to be minus 1.5 B's, and we've got half of a positive A, so that's half of an A. So let's tidy that up. Positive B minus 1.5 B's is going to be minus half of a B, and we've still got plus half of an A. Okay, let's now do the second part of our straight line, which is vector location M to location C, described in vectors A and B. And we're going to talk about, looking at our diagram now, how we get from M, which is the midpoint of PB, all the way over here to C. So we're going to do this again in two parts of a journey. We're going to do M to B, which again is half of the vector we discovered in part A. So we'll put that in first. So we've got half of the vector minus 3B plus A. And then looking back at our diagram, which we added in a moment ago, the part B to C is vector A with the correct direction of travel, because it was the same as the vector over here. So we can add into that plus a positive A. Let's now expand this like we did over here, so we end up with minus 1.5 B's plus half of an A plus this A, which was the second part. Let's tidy all of that up. So we end up with minus 1.5 B's plus 1.5 A's, which has come from this half of an A here and this whole A here. Now, here's the really important part. To be able to demonstrate that lines are parallel, and lines in this question are straight, we need to be able to demonstrate that they have the same gradient. So the first thing I'm going to do is I'm going to factorise both of these vectors. So here I can see that I have half as a common factor in both parts. So the half is going to come on the outside, and inside I'm going to be left with negative b plus plus a. What we have here is we've split this into two parts. We've split it into what's known as the scalar, which is kind of like the multiplier factor, and we've split it into the gradient, which is going to be the slope of the line. If we do the same over here, if we can find that this gives us the same gradient, then as I said at the beginning, we can demonstrate that the lines must be straight. So here and here we have a common factor, which is 1.5, which is going to be our scalar. And then here we have negative b, and we have positive a. So we can show now that they have the same gradient, therefore the lines must be forming a straight line overall. And I would summarise that to the examiner by saying both parts of the line have the same gradient, therefore the line must be straight.